Good evening and good morning to the participants here. So, welcome to this 61st CREE talk. Today we have a special guest, Shri Ashok Wankhede. Currently, he is a mentor to one of the CBD institutions, which is VNIT Nagpur. But he is also an alumni of VNIT Nagpur and has been an outstanding scientist at BARC, where he retired recently. So he brings an experience in actually working on very complex machinery and tools and looking at indigenization requirements within BARC. So with that brief background, I will request Mr. Ashok Wankhede to share his experience with this particular area, which is called turbomolecular pumps, which is one of the complex requirements in the BARC. So over to you, sir.
Thank you, sir. So actually, BARC works on various products, mainly for nuclear side and then defense side, mostly reactor side mainly, but quite a lot on defense side also. So I was there in one of the group where mostly defense side was the agenda, and a lot of advanced technologies which are import substitute were working on. So you can say 37 years of my BRC, I work on the such technologies only. And then there came some requirement from government that societal important products has to be taken out from these technologies as a spin-off. So we started working on this under ATMANIRBHAR BHARAT program when it was launched by Government of India. So quite a few products were taken up for development. So magnetically suspended TMP was one of these. My organization of presentation will be TMP, then motivation, real challenge, system block diagram, stages of development, user trials, creativity and innovation, technical challenge, deployment challenge, and then summary. Now, what is turbomolecular? Actually, TMP is a very known term in vacuum people or vacuum equipments, wherein turbo is the enhanced version or enhanced vacuum, which is considered as -6 and above vacuum. The equipment which is used for generating this kind of vacuum is called turbomolecular pump. And it's actually mechanical kinetic vacuum pump, meaning mechanical systems.
Could you explain -6 vacuum? What is
-6 millibar, sir. Millibar.
Oh, okay.
Yeah. So wherein mechanical impellers they rotate, which is called impeller blades, and gas molecules it drives down, which I will come subsequently. And these impellers are rotated at very high speeds. Because of that, the finest particles are very less number of particles. If they are present, they get driven down. Then if it has to be rotated at very high speeds, then there are two options, either ball bearing or magnetic bearing. Magnetic bearings have come up recently, which has got a very special importance, which we will discuss. Then it has got a multiple compression stages on the rotor and stator blades. That also will discuss. And it needs very compact and efficient high-speed motor. Compact in the sense that pump sizes are very small, so it has to fit into that. Efficient means it should not dissipate heat, because heating inside systems, impellers, etc., they are going to change the material properties, they are going to change the pumping speeds also. So temperature also has to be controlled. At the same time, it will consume more power also. So controller also takes a lot of power. So all these requirements need compact and efficient high-speed motor. Then it needs backup bearings, because these impellers are running at very high speed, typically 20,000 RPM and more. Up to 1 lakh RPM pumps are people have made. So once there is some problem, it touches, then simply it will crash. So there has to be some backup bearing. It will simply land on those bearings and save the system. Then these pumps are designed as per the operation requirements. Operation requirement in the sense for if it is for accelerators, it needs horizontal mounting. If it is for plasma research, then it need to work under the high magnetic fields. So it has to be maintained as, and designed as per the requirement. Like electron beam welding machine, it has to evacuate the gun. So it has to be very compact, and its evacuation properties have to be very different. That means it has to evacuate it very fast, because every cycle that welding has to be, that throughput has to be increased. So evacuation has to be very fast. So there are various kind of applications. Based on that, these pumps are designed. Then now what are the important specifications people look for? First is ultra hand and cleaner, ultra high and clean vacuum. That means for bearings, you don't need to use grease or any other substance. Otherwise, it will go simply into the vacuum. And pressure greater than equal to 10 to the power minus 6 millibar vacuum. Then pumping speed required is 50 liter to 3000 liter per second. Then these pumps need, turbomolecular pump needs backup pumps also, backup vacuum, 10 to the power minus 2 to 10 to the power minus 3 millibar. If it comes, then only it starts evacuating, because its design is like that, turbo. Then working speed is 20,000 to 60,000 RPM. Then minimum vibration is required. For that only magnetic suspension is a must, because if you imagine the semiconductor industry where nanometer, 5 nanometer, 30 nanometer, 50 nanometer, 100 nanometer technology is there the vibration, while evacuation, the vibration from pump, because it is a mechanical and rotating component, vibration should not reach to the system. Otherwise, everything goes the problem. So magnetic suspension is the only solution for such kind of requirements. Then magnetic compatibility. As I said, in plasma research or reactors or in accelerators, there are lot of big magnets will be there for using acceleration of electrons and such things. So those stray magnetic fields will come out where these pumps are connected. So these pumps are supposed to work under that kind of magnetic field also. There are specifications for that. Then baking at 80 degrees centigrade. So before putting to the system or application, or before, after maintenance, when the system starts, these pumps are baked at 80 degrees centigrade for 2 hours, 5 hours, sometimes 24 hours also, to regain the outgassing rate which was initially required. So that it should have that capability. That means it cannot contain any electronic component, because baking at 80 degree for 24 hours means everything will go put inside. Then it is required for continuous operation. Once it starts, it has to work in days, months, years together. These are all the important specifications people look for. Then what are the application? As I said, semiconductor industry, particle accelerator, EBW machines, helium leak detectors, electron microscope, mass spectrometers, and recent requirement is quantum computing. And all these applications, clean vacuum is the only USP which is being looked nowadays. Now, what is the motivation? Such a complex and high value system, complex technology, there has to be some motivation. So let us see the market size, today's market size. The study period is 2020 to 31, where market size is 2026 projected is 21,000 crore, and 2031 it is 27,000 crore, and growth rate is 4.83%. And surprising to see that Asia Pacific is the biggest growing market and largest market in the world, wherein Asia Pacific has growth rate of 6%, and again, surprising is India consumes good number of TMP, about 15 to 20% of the total produced in the world. And with semiconductor mission in India, we will buy more turbomolecular pumps. So this is the motivation. I don't think there can be more motivation for this. Then there is a secondary market. There is a leak detector, scanning electron microscope, mass spectrometer, electron beam welding machine. All these manufacturers, their equipment cannot roll out of their factory without turbomolecular pump. So they buy from the original original OEMs, and they supply the equipment. Then if such a big market is there, then what is so great? Why there are no manufacturers? There are very less manufacturers for this. There must be some challenges. Let us find out. Before that, I would like you to watch one small video where the TMP impellers are shown and active magnetic bearing. These are two novel components in the system. They are shown. These are the TMP blades, stator and rotor rotating. Gas particles are shown how they are pushed down. Then there is magnetic bearing. This is radial bearing. It maintains the gap in the radial direction here. And there is axial bearing where it maintains the gap, air gap axially. Now real challenge. Once we have seen that impeller rotating blades and impeller stationary blades, they are rotating. They are rotating at the speed of 24,000 RPM and more. And the challenge is the stator and rotor blade clearance is less than 200 micron. So you can imagine now that vibration limit required will be 300 micron radially and less than 100 micron axially, so that those blades don't touch each other. Then preventing impeller crash is the biggest challenge. This photograph shows that how years of experience, years of manufacturing technologies, years of assembly lines, and all this can go waste in the moment you switch on the TMP. Such blades we have within 3 years of development, we might have lost some 20-25 systems, which were individually costing about 2 lakhs plus. So you can imagine with this, what is the challenge. Now challenge need to be tackled. Then all these items needs to be considered for preventing that crash. And system design has to be done and it has to be simulated first. Before that, one should not go ahead. Then active magnetic bearings only is required for precision gap control. Then impeller design and innovation is manufacturing. The impeller design is very complex. It needs innovation. Then efficient building motor, I mentioned earlier. Then backup bearing, battery backup and regeneration in case of power failure, vacuum feed-throughs for taking out connections, then intelligent electronic controller and interlocks. These are all things needs to be considered for the efficient and reliable operation of the turbomolecular pump. This is the system diagram where this is the impeller, then these two are radial magnetic bearings. This is the thrust bearing or axial bearing. There is a BLDC motor. This is the controller blocks where power supply, then through power amplifier, position sensor for sensing the gaps, then controller. Then there is a battery backup in case of power failure, then power supply for master controller, and then BLDC controller, separate power supply. And in case of power failure, BLDC controller, it acts like a generator and it regenerates and supplies voltage to battery so that safe landing is achieved. This is the cut view of one of the turbomolecular pumps we developed, where it shows impellers, stator and rotor here. Then top passive magnetic bearing. There is a passive magnetic bearing using NdFeB magnets, which carries the weight of the total weight of the rotor under suspension. Then there are two radial magnetic bearings. There is a thrust bearing. There is a motor here and there is a feed through here with position sensor axially and radially with the bearings. Now let us see what magnetic suspension is. This figure shows one of the radial magnetic bearing, wherein these are the stators which are made out of stampings, SCRGO, typically 0.18 millimeter thickness. There are poles generated out of this to X and Y direction both. So there are 2 degrees of freedom here. And there is a position sensor for X and there will be for Y also here. So if rotor comes closer, then current in the coil reduces, here it increases, and vice versa. And this controller controls the bearing. You can see this equation. Force in the air gap is proportional to I square by G square. G is the air gap. I is the current through the coil. That means if rotor comes closer to the pole, forces are going to increase by I square. So this said it is a positive feedback, so it needs to be controlled. Moreover, it is very non-linear behavior. So this controller algorithm has to be very complex, which our people have developed. And it can generate a lot of properties. The required properties, required gap can be set and controlled. This is the physical view before epoxy casting. Basically, this will be epoxy casted, where these are the one position sensor, another is here, and this is the air gap. And these are the coils. Now, impeller, rotor, and stator. So the impeller is designed. It is shown in the figure. This is stator, rotor, and this is stator. Stators are made in two halves. One is inserted from this side, another is inserted from this side, like this. And outer rings are put for protecting them. So one by one, like bangles, they will be put. That means if you assemble one rotor and stator, and you go to next, and you go to next, bottom side you cannot see. That is the meaning. That means this fitting has to be very, very perfect. Then in this, the stator stress analysis is done. You can see the stresses here, where material selection, manufacturing, fitting and shaft and assembly, all this point of view, this design was completed. And rotor dynamics was also done, where this rotor, this particular rotor is simulated here in the ANSYS, where we can see that this is the axial bearing, this is radial magnetic bearing, this is another radial bearing, this is thrust bearing. And this is free rotor, which is simulated. And we can see this is a subcritical rotor where 780 hertz is the critical frequency and 18 hertz and 12 hertz are the system criticals. And responses are here given. Without damping, we can see that amplitude is going up to 600, above 600 for this node and above up to 300 micron in antinode. And with magnetic bearing, with active damping, we can see that this response is reduced below 180 microns. So this is radial. So radial 300 is allowed. So 180 micron was accepted. So we went through. We were through with this analysis. Then stages of development. So stage one was developed using very big housing where a lot of sensors, etc., were to be put, and one dummy impeller was incorporated. Dummy impeller was having actual radius of the impeller and mass both, so that rotor dynamics doesn't change. This was tested with all the other components, and all vibration levels, axial, radial, all were simulated using injecting certain signals in the active and axial magnetic bearings. Shocks are also, waves are also generated and they were tested. A lot of instruments were put inside and they were tested. This almost went for 1 year. Then we went with a actual rotor only. No rotor blades were put and it was run, thinking that at whatever design it was done, with whatever stresses were expected, it is following that and rotor is not breaking. Those vibration were measured. Photographs, high-speed camera was there. Some photographs were taken up to certain speeds and it was made through. Then final system were made and rotor and stator blades were also assembled and the system was tested. So these three stages almost completed in 3 years' time. Then evolution of controller. This was the preliminary first controller having all facilities, vibration analysis, temperature measurement, shock measurement, lot of things. Then it went through a second system. Then third and final controller was a single with 19-inch rack. Then once you make this system for turbomolecular pump, there is a standard test called as a qualification test, where lab testing, or we can say testing at 100 hours continuous operation is done in actual environment. So this backup pump was put here. We put rotary pump here, and then this discharge port was plugged and penning gauge was put here, and inside input side Pirani gauge was put. And this controller with over voltage, under voltage, and all sorts of tests, power off, power on, all sorts of tests were conducted, and 100 hours test was generated and completed, generating all types of data, including temperatures of motor, temperatures of stator, temperature of impeller, temperature of thrust bearing, and all. Everything was measured and it went through. You can see power here, it is showing 205 watts. Then user trials were conducted. First user trial was conducted in BRC in one of the group where they make electron beam welding machines, which are available for technology transfer also. Top companies have taken also. And it was accepted for adoption for EW machines developed under ATMANIRBHAR BHARAT mission. So this first pump went into one EBW machine, which was technology transferred. Second trial was conducted at IPR Ahmedabad, Gandhinagar, where hydrogen, helium, and nitrogen and air, all sorts of tests were done because they do plasma research and their good number of pumps they consume. So there they completed 350 hours of test, then pumping speed measurement they conducted, leak rate test they conducted, and baking 80 degrees for 2 hours they completed. And they certified that, and finally leak rate test also they completed, which was very, very important for their system. So they also certified that it can be used. And then performance evaluation at RRT at Indore, where accelerators are there, Indus 1, Indus 2 like that. They use hundreds of TMP, which are only imported only. And photograph is not available because of some their own reasons. They have not given the photograph. So that was also completed and they have certified that it can be used for the application now. Then creativity and innovation. So what we were failing because of the impeller only, first initial time, because impeller was crashing, because main reason was gaps were controlled, temperatures were under control, everything was under control. Still it was failing because of the assembly of the impellers, because there will be manufacturing tolerances, there will be deflections because of the temperature. So all those things has to be accounted, and there will be assembly tolerances, assembly errors. So because of that, if any one stator ring gets misaligned, then everything goes wrong. So what our people have done was they have designed the impeller, and this whatever world use traditional impellers, they use one single stage by stage they manufacture using conventional milling and machining, 5-axis machines of course, and then they put one by one up and then rivet it. Here, what we have done with laser metal sintering based additive manufacturing process. We manufactured single rotor, which is integrated rotor, which was hollow inside, and stator were made into two halves, all the stator combined. That means you can inspect both the components with 3D machines, all the gaps you can measure, here also, and then you can assemble. Once it is assembled, all gaps are whatever assembled, it will stay there and there won't be any problem. And the advantage here was this was hollow here compared to this. So compared to this, it was 1.6 kg, this was 800 grams. So because of this, our rotor dynamics becomes relatively simpler. It consumes much less power compared to that. We will see later on that also will come. So this idea was patented, and my colleague here has given photograph like this only. I'm very sorry for this, but I think one can see also this. Then where do we stand? There are very few companies who make active magnetic bearing based TMPs. One of Germany, England, Germany again, and India. So one can say that they have become third country to have AMB suspended TMP. There is a comparison one can see that our weight is little bit more because of the housing which needs to be optimized. Then power consumption is the lowest here, and we don't need any cooling. We need natural air only. That is because of the efficient build DC motor and aluminum housing. So I think it is at par with the other this thing only. All are 400 LPS pumps, which are used in the maximum applications. there was an exhibition in DA, so there it was displayed and it was appreciated like anything. This pump was running with backup pumps and everything inclusive continuously 3 days in the exhibition without stop. Then technical challenges. Then magnetic suspension. Actually, all the challenges our group was working for more than say 20 to 25 years, but for different product, defense equipment and all that. So for us, magnetic suspension already we were having 45,000 RPM. The setups were there, everything was there, manufacturing facility was there. Then BLDC motors, we are the only place where high-speed BLDC or any other motor high-speed was being manufactured. Then backup bearings, this was new for us. So with control clearances and fitting tolerances, those bearings were found out. Then outgassing issue. This is the most important in the any vacuum system because there will be we need greaseless manufacturing, then epoxy, all these coils, etc. They will be epoxy casted for the safety and handleability. Then baking will be done, but still there will be some components which first time it lot of outgassing will take place. So let us say once you start backup pump -2 millibar vacuum, it will in the first run it will come after say 3 to 4 days only. So we start thinking what is happening. There is a leak or something. But these are outgassing issues. We were aware of these issues earlier also because we are operating vacuum-based systems only. So all leak detectors and other things were available. But if you see the volume of the technologies, these are the technologies which are available only in DRC only at one place. And it's an effort of some 20, 25 years only. So all these things were available. We were making reliable electronics with redundancy, temperature compensation, and doing heat run test for Navy also. So we were aware of all these things. And impeller blade was new for us. So that is how that lot of time people took to develop that impeller blades. Finally, we tried few numbers, almost 20, 25 numbers with the conventional manufacturing. And we failed miserably. But later on, one of our colleague, mechanical colleague, my junior, he started thinking in independent direction. So he got that idea and that was through. Now, after that, till today, yesterday only I talked to people, taking some data from them. Till today, they have not failed any impeller because that perfect assembly and backup bearing. And finally, the laser balancing was required for very fine balancing because this system needs vibration less than 100 micron axially and 300 micron radially, less than 300. So this rotor has to be balanced very perfectly. It's a very high grade balances. I think G1 is the requirement. And you can see this is the laser equipment and this is the rotor put horizontally and this is laser spot. So using this laser technology, you can remove the moss less than 1 milligram at a time. So very fine balancing is possible. That was done in-house also because this technology also we have developed for our high-speed system. So it was available. Only thing fixtures etc. need to be made available, which was made. So all these technologies were the challenge, and it was gone through. It was conquered, and product was made ready. Then deployment. So most difficult was deployment. Deployment in the sense that whenever our people tendency everywhere is that when you start buying imported equipment, then if written 400 LPS, we simply agree, yes, it is 400 LPS. If it is written, it will give this much vacuum in this much time, we agree readily because we believe them because a sort of a proven systems. But once you develop your own system and start telling this is 400 LPS, this will generate 10 to the power -7 millibar vacuum and all sorts of things. There will be a lot of questions will be asked. So these are the things which were taken care and finally we could go through like documentation. We Indians, in my personal opinion, we are very bad at documentation. We don't want to document much. So design document, operation manuals, troubleshooting manuals, all these things are the important component of the deployment. Then test results. We do endurance test, quality check, capacity measurement test. But again, those test results, etc., comprehensive test results we don't like to share with the people. But yes, some results to convince people, they have to be shared. We did that also. Then validation of results. This is one of the most difficult things we faced, because capacity, how to measure the capacity, because capacity measurement beyond 10 to the power minus 3 millibar is very, very difficult. There are no equipments available, no instruments. You have to go from basics only. So what we did, we tried to devise a system where standard volume of 5 liter was taken, welded vessel, stainless steel 304 vessel, polished very nicely, having only one inlet and one outlet port for measurement of vacuum and one connecting the turbomolecular pump. And we started measurement, putting the turbomolecular pump, started measuring the vacuum. After waiting and baking for 8 hours at 80-degree temperature, that means outgassing has taken place completely, putting backup vacuum as a what we call oilless pump. There are some available with our people. They don't use oil, etc. Those pumps, and after 1 week, pump measurement started, and only time was the measurement from reaching 10 to the power minus 3 to minus 4, minus 4 to minus 5, minus 5 to minus 6, like that. And then same procedure was repeated with labeled pumps, same TMP based pumps which they were having, and same procedure, and they found that yes, it is at power percent. And this was the only method available with us. And it took almost 4 to 6 months to conduct this test. But there was no other way, because deployment, once you develop such a product, deployment is very, very important. Deployment, if you don't do that, it will go waste. So these things were done. Then compatibility with the equipment. Then there is a difficulty that wherever they want to connect, there will be different kind of port. There will be different size of the port. Some places there will be bellow connection. TMP generally don't recommend bellows, because bellows hold a lot of outgassing material like dust, gas, oil particles, like that. So TMPs are generally connected to the mouth only. That is how the TMP has a bigger mouth connecting port. But some people, they have a system requirement, they have constraints, so they want to connect with bellows. So though they have to make available that kind of port, so attachments were made. Then purging requirement, they want to purge because there is some, let us say, electron melting application. Electron melting application, before melting any material with electron beam, they want to purge with the, let us say, nitrogen gas or so, or argon gas sometimes. So you, not only their chamber, but they want your TMP also should be purged with that. So anyway, purging port was made available, which is a standard requirement. But we thought, ki, let us see, purging to baad mein dekhenge, like that. But that was another difficulty we faced. Then baking requirement, and they don't want to put external coil. They want integrated coil on the housing of the TMP. So that was incorporated. One jacket kind of thing was made with coil and hot water circulation, and some places electrical connection, because some places they were not preferring electrical connection. So hot water circulation coils, copper coils were put. Then user connect interface. Nowadays, connectivity is also a big requirement, because everybody want to go through internet now, because IoT is the requirement nowadays. So IoT was incorporated. So With incorporation take a lot of time because a lot of interfacing has to be done. A lot of changes in the control electronics was required. So this also take quite some time. Then cost, finally cost, because always your product will be compared with the imported one. And since if you are making some developing, then making few numbers, let us say 20, 25 numbers. So your cost is going to be higher compared to the equivalent market product, which is made in millions. So here also there is a problem because everybody has got project where they got limited money. So they want to spend only allotted money only. So there is a limitation from their side also. So we have to give some discounts also from our project. So all sorts of these kind of things were done for deploying to our system because we knew that unless it was deployed, it is deployed, it's not going to through. So only seeing is the believing. So few numbers should get deployed. So all sorts of things. 1 year, almost 2024, after my retirement, I retired in 2023 beginning. Up to 2024, they were doing all these things only. Of course, I was connected with them because it was a pet product of mine developed. And one appreciating thing was it was developed in COVID period. 18 we started, 21 we completed one first prototype. So, and it could complete in 3 years time because of, I will say Corona only, because no other work was there. Only this work we were doing. So all our officers, etc., everybody was working in shifts. Some 18 officers coming one day, 1/4, second day, 1/4 like that. And they were working from home. So I really appreciate their things. So all these deployment challenges we faced, and it is worth to note and know for a product development person. So what kind of deployment challenges will be there, which generally we don't think. We think this whatever is we give, people will take. It is not like that. Then what is latest? So yesterday I talked to my people. Still one group is working on that. They have completed 400 LPS, 1000 LPS, and they started using DE also manufacturing. Of course, manufacturing is done by outside parties only, tender basis. Then 80 LPS, this 80 LPS. Recently it was deployed, and this is a very hot product because this 80 LPS system is used in leak detectors, electron beam welding machine, mass spectrometers, all smaller systems they use, and they are consumed in huge numbers. So there is a very big demand. But this is not with active magnetic bearing. This is having passive magnetic bearing using NDFEB magnet and then backup bearing like that. And his speed is also very high. This works at about 40,000 RPM, while this was 24,000 to 30,000 RPM. But this kind of speed is okay for this. So these things are available, and maybe this will be available for technology transfer also. Some of us can opt for technology transfer also because this is not manufactured in India till today. In summary, summarizing, this totally suspended TMP technology is developed. Then technical challenges, testing challenges overcome, deployment challenges understood. Then associated technology advantage is huge, like TMP. While you develop TMP, there will be magnetic bearing, there will be motors, there will be vibration, there will be analysis, there will be controller, there will be a lot of things gets developed. So you get to develop a lot of infrastructure and expertise also. Then high value import substitute. So there is a good market. All manufacturing facilities are available in India. Not a single component is imported in this. So everything can be manufactured in India only. The market potential, as I said earlier, also about 30,000 crore rupees. And with semiconductor mission, huge demand expected in India. So with this, I think people should come forward, industry should come forward and take technology from BRC. Anyway, they have a technology transfer group. People can approach, websites are available, and technology can be manufactured. And with the given industrial development, technological development in semiconductor mission, I think this product is a huge requirement, will have huge requirement, and nothing like indigenous technology where maintenance will be easy, spares will be there available, cost also can come down. With this, thank you. This was the first pump, and this was the what I call what I call nameplate, which was made for this first TMP.
Thank you, sir, for a very detailed presentation on the particular experience. I'll open the floor for any questions from the participants.
May I ask something? Sudhir,
Please
can
go
you
ahead.
hear me?
Yeah, please go ahead, Shyam.
Yeah.
Okay. Thank you, Dr. Wankhede. It is uh, it's a very nice presentation, and it's so heartening to learn the achievement, the engineering achievement of your achievement and your colleagues at BARC in developing such a fine product. My question has to do with the part that you mentioned about the cost and its demand and the price. As you mentioned, if I understood you correctly, that you the the since the number of units to be uh, sold or provided to organizations in India was only 30, as opposed to demand for tens of thousands because of the cost, because they would import it at lower cost because foreign manufacturers are making it at a very large scale. So my question is, does BARC have, I know they have a technology transfer unit, but does BARC have an active marketing unit or organization to actually proactively go out and find manufacturers who will take the technology from BARC to produce it at a scale and customize the product for individual uh, uh, customers? So like connectivity, etc., that you mentioned, so that the demand for this, so the domestic users would not opt for lower cost foreign versions, and the cost itself in India can be reduced by scale manufacturing. Is there a proactive action in this, or manufacturers have to come to BARC and ask them, do you have some technology we can use?
Yes, sir. Yes, BRC do have a technology transfer division, and we have a incubation center also at different places like Ararkat, Indore we have, Mumbai we have, IGCAR also, Kalpakkam also we have one. About this going out and outreach, we call it. Outreach is very good in terms they go to different industries, they conduct a lot of workshops, they conduct exhibitions. Recently, there was one some 2 months ago. So the problem is they proving the product. So supposing first thing BRC don't manufacture in mass.
Of course, of course.
It's not a mass manufacturer organization. They
No,
develop.
right.
With that 25-30, I manufactured with great difficulty because they said, no, that is not your job. But we have to convince them, telling that at least few numbers people should see it working. So DA is the biggest biggest consumer of turbomolecular pump because accelerators, then plasma research in IPR, and all electron being welding machines, a lot of things, leak detectors, etc. So unless you show people working that your product is working reliably, people will not come forward even for technology transfer. Reason being, it's a very high value. To just give an example, 400 LPS active magnetic bearing based turbomolecular pump has cost ranging from 25 to 30 lakhs of rupees.
Mhm.
Okay, imported I'm telling. Ours will come some 4, 5, 10 lakhs more only because of these
Mhm.
low numbers. So
Volume bigger. Mhm.
yeah, such a high value product, people don't want to invest money just like that because
Yeah.
it is not proven. They say it has to be proven. So this was the effort to show that it is proven, and nobody will put your pump just like that in their system and put their time and money and all that. So we decided that we have so many systems working, lot of accelerators are consuming. So let us say 10 pumps at RRCAP, we'll put our pumps. RRCAP Indus 1 and Indus 2, we have thousands of pumps.
Mhm.
So like that. Then IPR Ahmedabad. So all those three places were selected in such a way that good numbers can be deployed there. And maybe 1 or 2 years of continuous operation, you also get confidence and the people also do. And a lot of manufacturing defects also comes into picture. Design changes will comes into picture because unless you deploy and run it for months together on actual system, you won't come to know what are the systems. So upgrade is not possible that way. So that was the idea.
Okay. May I mention, I'm here at Yale University, and I've been in US for 55 years.
Yeah,
And the way it works in high technology research environments like BARC in American universities is that the researchers like Ashok Wankhede, for example,
Mhm.
they are encouraged to, while they are working with the university, to also create their own companies with uh, with the help of venture capital from outside
Yeah,
to commercialize their develop products and inventions. So once the developer in the research operation himself or herself is involved in the company which is trying to produce it at a scale and commercialize the technology, it becomes far more believable because
yeah,
his or her own time and money is involved in it.
yes,
And I know it creates in Indian environment, I don't know how common it is. Will, for example, Bark allow Ashok Wankhede, when you were working at Bark, or now for that matter, to start a company with the help of some capitalists to to commercialize the product that they developed within the BARC organization, even though most of the cost of development was BARC's cost or government cost, and a good part of the profit will go to the private capital. But in
yeah,
the US, this is how these advanced technologies get commercialized. And the permitting now, that can create a lot of conflict of interest, though
yes,
it has to be managed with the rules and proper supervision. But it is also true that the resources of government and research organization are being used to commercialize it, and they are gaining the benefits of this.
yeah,
Any number of examples, the RNA vaccines, for example,
yeah,
there were all that work was developed in NIH, in the government research, government
yeah,
funded research, and then it was commercialized. And they don't worry too much about it because to the country, to society, the advantage of that is very large. I'm not arguing for it, but I'm just asking you, does the Indian
Yeah,
system will simply say,
yeah.
Ashok, you can't do it because you will
Yes,
profit
yes.
from it?
See, PRC has got that policy where technology transfer can be taken by industry, assisted by their employees. That policy, but that that is true when that product is available for technology transfer. This particular product, which was turbomolecular from AMB based, active magnetic bearing base, is so far they have not released for technology transfer because they believe that it has to be proven. While that ATLPS they are releasing now immediately. So that is possible. The reason
But
being, it's a very high speed product. It has got active magnetic bearing technology, which is also sort of a protected technology. Then motors, high speed motors, which are used in very specific applications. So all those things are there. And moreover, once it is proven, then only otherwise the name of the institute goes. Here, so their thinking has to change because they are not into product development. BRC is not into product development. They are into nuclear engineering, then sort of like that. So for them, this is a spin-off product, so they don't want to spoil name just like that. So they decided, because I was involved in a lot of discussions 1 year before my retirement about all this with Chairman DA Vyasa, KN Vyasa was the chairman. Mahanti, Dr. Mahanti was the director. Now he is chairman. So their thinking was like that. It has to be proven because it has got a lot of things. You have seen if little bit something goes wrong, that impeller burst. So that is how they are little skeptical about the things and they want to get it proven. And as such, they are the biggest buyer of turbomolecular pumps. So they feel ki let us try at our place first, number of. They want to give it mass manufacturing for outside, but they will buy it like that
uh,
in the
I
initial time.
understand. I
Yeah.
understand that argument. Of course, it has to be given very careful consideration.
Yes.
But at the same time, unless they allow the researcher staff to begin to think about commercialization
Yeah.
at a reasonably early stage until everything is proving and nailed down. So much time would have passed
Yes. Yes.
that somebody else abroad would have developed a better product.
Correct.
So it
Correct. Correct.
has, in any case, I think there are a lot of interesting policy issues in this because I have often wondered why, even though such wonderful work is being done at BARC and other Indian research organizations, India is not able to compete in the international market
Yeah.
to bring such products to the market and sell them all over the world. And we need to, in my assessment, we need to have a detailed discussion and reconsider the policies because they are very difficult issues of conflict of interest,
Yes. Yes.
use of public IP and everything. Let me stop here, that's all. Let others.
Yeah.
Okay.
One else has any question or clarification to ask? Please unmute and you can ask.
Yeah. Thank you very much for this really detailed presentation. As a person who teaches product design, the point you made about documentation is very, very fundamental. We don't teach students that they have to document their work. When I was teaching my product design course, 40 to 50% of the grade was documentation. This is the only way to force them to think about writing down everything, collating, and having a history. Also give exemplars of famous engineers' notebooks, whether it is Da Vinci or Edison or others, to show the importance of documentation. And I think you pointed to a very big lacune in the way we think about documentation as somebody else's job. If you built it, you should know how to operate it. That means you should be able to write what it can do.
Yeah.
I mean, simply that is the logic. So that is one point. And the second point you made, at least people coming from the academic environment to realize, to conception, to deployment, to transfer is a very long process, especially when you are developing all the pieces yourself. The second point in that is you had a collective memory of doing these things for about 25 years.
Yeah.
So you had the knowledge base available to you to be able to compose those things which you did not do before to solve a particular problem. I think valuing the collective knowledge of the people and years in institutions, I fear, is slipping away. And that is something I feel is very important to teach our engineering students about. These are my comments here. Thank you for your nice
Yeah.
presentation.
I think I just add to it, sir. Now the things are very going in a different way. Now I go to VNIT Nagpur, and because of these mobile phones, no, nobody want to write.
Mm-hmm. Mm-hmm.
I generally carry one notebook and I write this one.
Mm-hmm.
If
Mm-hmm.
Sudhir sir sees me anytime there, he will see this notebook with me. I encourage them, you write down, but they don't want to. They're so hesitant to write down anything.
So that is why I think in the universities we have to put a penalty, grade. They
Yeah.
die for grade, right? Tell them 50% of your grade is documentation. And the students who do the best documentation get higher grades.
Yeah.
In our case, the projects went for 3 semesters. So the students were not, the same students were not there in the next semester. So it was very important to make them do it.
I think that should be done actually.
Not valid.
So, yeah, any other questions?
Can that be voice recorded in phones? So documentation is voice recorded and then transcribed.
Yes, it is
It is
possible. Mhm.
It is there, sir. Even in Bhashini app also it is there.
So I
I
mean,
think so.
they can do the writing on the phone.
Well, the problem is not the writing, it's the editing part and connecting the pieces together. You know, we can record everything, but it cannot organize itself. That's
Sure.
where the trouble comes.
Shyam, in fact, this part is very key, right? But some places we cannot maybe penalize people. We cannot force them to write down. There are in India, it's all different. Okay, but yes, today they can switch on a mobile phone. They can do some other work. The entire lecture after that, it is going to summarize it in whatever 1 page, 2 page. To whatever level you want to understand, it can give you. So Gemini or Perplexity, all these things can give you this in a very shortest form possible. So and we really cannot in India force people to not use mobile phone, etc. Somewhere they will end up using. So at the end of the day, they get whatever the summary of 1 hour lecture, and they don't want to even follow that. But this is not valid certainly for all the students. We can't generalize it, but now it is becoming a way of life, unfortunately.
I think we have to think about different ways of making them do this, not just grades, but also have sort of sessions in the class once in 3 weeks or so, especially if they're doing product design, to get them in groups and start reflecting on what they are. I'm worried about this Gemini and other things because they remove reflection completely. We have to create that space ourselves so that they can have a space to reflect among themselves. Faculty can participate in them as a way for them to go beyond the Gemini and ChatGPT to say there is something deeper, which is important.
Okay, so thank you, sir, Shri Ashok Wankhede, for sharing your detailed experience with this particular product. The entire cycle of right from design to deployment, a lot of valuable inputs are there in terms of how to approach and so on. So thank you very much. For the participants, the next talk will be on 4th March. It will be by Professor Shyam Sundar. Sir, please send us the
Innovation and
abstract.
economic growth.
Thank you, sir.
Yeah,
Innovation and economic growth.
okay, sure, sir. Thank you very much. Thank you all.
Thank you, sir. Thank you all. Yeah.
And this talk will be on the video of CREE
Yes.
website.
Yeah.
Thank you.